So the first one, the fractional distillation of a crude oil usually produce large quantity of heavier fractions. So when we do fractional distillation, it produces heavy fractions. And these heavy fractions, we crack them and we form the lighter fractions. So the question is, the market demand is for lighter fractions and for more reactive alkenes. The heavier fractions are cracked to form a smaller alkane and alkene, as in the following example. So octane is there, which on cracking decompose to butane and butenes. Write a different equation for cracking of octane. So what else we can write? Any different equation. It's not having a fix. It's up to you. There are many possible answers for this. If one is alkane, the other one will be alkene. And how you will know one is alkane and another one is alkene? You can work out from the general formula, because the general formula for alkanes, if the compound is alkane, the general formula is CnH2n plus 2. And if it's an alkene, then CnH2n. So if the first one is C3 and H8, what will be the second one? Even you can produce hydrogen, that's also acceptable. So if first one I wrote C3 and H8, what will be the second one? C5H12 and C3H6 is also correct. So C5 will be there and H10 will be there. So I make propane and pentene. But it's up to you. You can make different. It's up to you according to the question. Because they did not restrict for a specific one, so you can draw or you can write any combination which matches with the original reactant. Cracking of octane can produce isomers. Isomers mean they have the same molecular formula but different structure. We call isomers. Draw the structural formula of two of the isomers. So we have C4H10, sorry, C4H8. It means alkene. And means there should be a double bond. We have to draw two isomers. You can use this screen annotation to draw the two isomers. Just a minute. Now you can use screen annotation to draw the two isomers. Or you can use a chat as well to answer this. Yeah, that's right. But1ene means a double bond between the first and the second carbon. This should not have hydrogen. This is extra hydrogen because carbon maximum can form 4 bonds. So this should not be there. You can also draw cyclobutane. That's also correct. Again, this one, this carbon, because 1, 2, 3, 4, 5 bonds you showed. So carbon maximum can form 4 bonds. So there should be one of them should not be there, either top one or bottom one. You can draw the cyclic one as well. So these are the three isomers: butanene or butene, butene or cyclobutane. Then give the essential conditions for reaction between chlorine and butane. Essential condition when alkane react with chlorine, like a substitution reaction. Essential conditions. So essential conditions for substitution reaction, it is ultraviolet light, or you can also say UV. And high temperature, but they only ask for singular here, not conditions. It's only conditions, so UV is the right answer. State type of reaction. State what kind of reaction occur when alkane react with chlorine. So alkane with chlorine, we call that as substitution reaction. The next part, the reaction produce mixture of the product. Give the name of the two products that contain 4 carbon atoms. What is the meaning of two products that contain 4 carbon atoms? As if you have, say, butane, which is C4 and H10, and it is reacting with chlorine, which is Cl2. So a substitution reaction, one chlorine enter, one hydrogen will leave. So the product will be C4 H9Cl plus HCl. Then because this is a chain reaction, this will continue. And what we call this product, it contains one chlorine. So we call that as mono. Mono means one. Monochloro, because there's a chlorine, and 4 carbon, it is but, and they will have a single bond in. So monochlorobutane. That's a one product which contain 4 carbon atom. Then this will be C4 H9Cl, the product of the first reaction, reacted with another chlorine molecule, again a substitution reaction. One chlorine enter, one hydrogen will leave. So it will form C4 H8Cl2 plus HCl. So two chlorine are there. So what we call when two chlorine are there, we call dichloro. And because of 4 carbon and they will have a single bond, so it will be butane. So what are the two products which are formed contain 4 carbon atoms per molecule? That is a question only, that the reaction produces a mixture of products. Give the name of two products that contain 4 carbon atom per molecule. So the first one is known as monochlorobutane, and the second one is known as dichlorobutane. And then there will be third one, trichloro, but they did not ask for the third one. They only asked for two products that contain 4 carbon atoms per molecule. Is it clear, this part? In the next one, alkenes are more reactive than alkanes and are used to make a range of organic chemicals. Propene is made by cracking. Give a structural formula of addition product when propene react with the following. So when propene plus water, what will be the product first? Propene plus water or steam. This is called hydration. The term hydration means addition of water. So it will form propanol. Alcohol will be there in the journal, so it will be propanol. So how to draw the structure of propanol? What you have to do, just 3 carbon atoms. Prop means 3 carbon atoms, and all means there is OH. And when you draw the term structural formula, so you have to show the structure. That it is, so the double bond basically will break and one side hydrogen is added. The two carbon which are having a double bond, one side hydrogen is added and other side OH is added. When it react with bromine, what will be the product if propene plus bromine? Propene plus bromine. So it will be dibromopropane. So dibromopropane means that two bromines are added to the carbon which are having a double bond. So if you want to draw the structure, the first one is CH3, the second one is CH, and the third one is CH2. The double bond you will break, and one bromine added to the first carbon which is having a double bond, and the second bromine added to a second carbon which is having a double bond. So this will be a product dibromopropane or 1,2-dibromopropane, because first and second position we have bromine. Another question: ester, fats and polyester all contain ester linkage. The term ester linkage means C double bonded with O and OH. The structure formula of an ester is given below. Name two chemicals that could be used to make this ester and draw their structure. But first thing, what is the name of this ester? What is the name of this compound? This is ester, but what is the name of this ester? So the part which is attached with oxygen is considered as a branch. So there are four carbon in the branch. And the part which is attached with C double bonded with O, that's considered as a chain. So four carbon, that's why it is but, because of four, and YL butyl. And because of two carbon atoms, so it will be butyl ethanoate. Butyl ethanoate is the actual name of this ester. So the first name is coming from alcohol. So which alcohol is there? What are the two chemicals which react to form this ester? So the alcohol is butanol. And what about the acid? So because the second name is from acid, so it is ethanoic acid. So the two reagents, two chemicals which react to form this ester is butanol and ethanoic acid. Then you have to draw the structure of two of the compound. So I want everyone to use screen annotation to draw this, the structure of butanol and ethanoic acid. Just a minute, I will use a whiteboard so you can have more space. Draw the structure of butanol and ethanoic acid and show all the bonds when you draw the structure. Butanol and ethanoic acid. It will be difficult because you are using mouse, so it might not be a neat drawing, but it's not an issue. The thing is, you express or show your understanding. That's the main reason why I want the participation from everyone.
Sir, this is like the one which I drew. It's incorrect for ethanoic acid, right?
This is C double bonded with O. It is atomic acid. That's correct.
It's correct. Okay.
Because H means two carbon and oic acid is for C double bonded with O and OH. This part is representing the functional group. Yeah, thank you for your participation. So this one alcohols are there, and this one is a ethanoic acid. Then draw the structural formula of a polyester such as styrene. So you can see directly they asked to draw the structure formula of styrene. So how to draw a structure formula for styrene? You don't have to draw monomer directly, you have to draw the polymer. So basically you have to practice this structure. I will draw the monomers as well, just for recall the idea that how a polymer is formed. So what are the monomers for polyester? Polyester, styrene. What are the monomers? So dicarboxylic acid, it's polyester means it contains ester linkage, and ester can be formed by alcohol and carboxylic acid. So it is diol or dicarboxylic acid and diol. I write in short here that dicarbo means dicarboxylic acid. So if you want to draw a dicarboxylic acid, these are the monomers I am drawing. So it is HOC double bonded with O and C double bonded with O. So this is dicarboxylic acid, and between them just draw a box to show that there is a carbon chain. And diol means that both side OH and between them there is a box shows that there is a carbon chain which does not affect the formation of this polymer. Now when diol react with dicarboxylic acid, if one side you remove H, the other side you will remove OH. One side H, other side OH. And what you're left with, that is a structure. Water will be there as a product because it is a condensation polymer, but you don't have to draw water here. Why? Because they only ask for polyester. So it will be O, C double bonded with O. Then there is a box, C double bonded with O. OH and H being removed, so oxygen will be there. And there is a box, and put a bracket and write N. So that is a polyester such as styrene, which is having an ester linkage. So in exam, you have to just draw this one. You don't have to draw the monomer. The reason why I drew the monomer to explain this formation. Suggest a use of this polymer where we use polyester. What are the uses of the polyester? It is used in textile industry, clothing, rope. That's correct. Even packaging, bags, even polyester bags are there. So there are many uses. Package, so ropes, clothing, bottles, packaging, bags. The large area of Amazon rainforest are cleared each year to grow a soya beans. The trees are cut down and burned. Why do these activities increase the percentage of carbon dioxide in the atmosphere? So it's of 2 marks. So this is not related to organic, but it is related to carbon cycle. So what is the reason why the percentage of the carbon dioxide increases when we cut the trees and burn to grow soya bean? Because what's a effect? Burning produce carbon dioxide that increases, and as we are cutting the trees, so less rate of photosynthesis. That's why the combustion release carbon dioxide. That's right, the burning or cutting the trees stop them from absorbing carbon dioxide. So that's why it's of 2 marks. One is combustion increase amount of carbon dioxide, and second one, cutting the trees reduce photosynthesis. Soybean contain all the three main food groups, two of which are protein and carbohydrate. What is the third group? Third food group, which we discuss in condensation polymerization. Lipids or fats, you can mention that. Then draw the structure formula for carbohydrate such as starch. So we have to draw the starch. So what are the monomers? Monomers are the diols, simple sugar molecules, which are actually diols. So it's easy to draw the structure of starch. These are the monomers. Again, you don't have to draw the monomer directly, you have to draw the polymer. So how to draw this polymer? If one side you remove H, the other side you will remove OH. One side H, the other side OH. So it will have oxy linkage, oxygen is there, then this box means the carbon chain, then O and H, OH and H are being removed, then O, then there will be another box and OH is being removed. So put a bracket and write N and see 3 marks are there. So what is the distribution of the marks? 1 mark is for mentioning this oxy linkage. 1 mark is for using the same symbol for the carbon chain, like same symbols, that's the second mark. And continuation, 1 mark is for putting this bracket and writing N, that's the third mark. In the next question, compare the structure of a protein with a synthetic polyamide. Polyamide means nylon. The structure of a typical protein is given. If I draw the structure of nylon is when dicarboxylic acid react with diamine. So dicarboxylic acid, both sides there will be carboxylic group, and then diamine means amine, both side amine groups will be there. This is nylon, what I am drawing now, and protein structure is already shown or given to you. The question is how they are similar, how these structures are similar to each other. How the two structures are similar. So both have the same amide linkage, same linkage is there, same type of bond, amide or peptide linkage. As you can see, C double bonded with O and N, and C double bonded with O and N. So both have amide or peptide linkage. That's a similarity. And both are formed by condensation polymerization. How they are different from each other. How the two nylon is only formed by two monomers. Yeah, that's right. Nylon protein has many monomers. That's correct. Where nylon is having only two monomers. Then when you compare the other part, identical ends are there for in case of the monomers have identical ends in nylon, like example dicarboxylic acid and diamine. But for monomers, amino acid, it contain one side amine group is there, another side carboxylic group is there. So two different groups are attached in the monomer. And nylon is a synthetic polymer, whereas protein is natural polymer. And protein can be hydrolyzed. Like we can do hydrolysis of the protein will produce a monomer, but nylon cannot be hydrolyzed. And this one which I already mentioned, that protein contain different ends, different groups at the ends, monomers, where for nylon identical groups are attached at the end of the monomers. In this question, lactic acid can be made from a cornstarch. It polymerizes to form polymer which is known as polylactic acid, PLA, which is biodegradable. Suggest two advantages of this polylactic acid compared to the polymer made from petroleum. So what are the advantages of making a polymer which is biodegradable and we are using a cornstarch instead of making a polymer from the petroleum? So it degrades by the environment over a time, so does not pollute the environment. So biodegradable means it will break down naturally, and you can see it is made from a cornstarch. Cornstarch means it's a renewable source. Like we can use it again and again. Like we can grow the corns and we can extract the starch from them and make a polymer. But the disadvantage of this, here we have to just mention the advantages of making a polylactic acid compared to that which is made from petroleum. So it will reduce the visual pollution or need for the landfill site, or it is less dangerous to the wildlife. Why? Because it does not remain in environment for a longer period of a time. But you don't have to mention release uh, like in terms of toxic gases, because it's not about burning. We are relating that with its decomposition. So break down naturally and reduce the pollution, visual pollution or landfill sites, reduce that. And second thing, it is made from renewable source, so we can grow again. The next one, the structure of PLA, polylactic acid, is given below. What type of a compound contain the group that is circled? What we call the C double bonded with O and O. So we call that as an ester. Complete the following sentence. Polylactic acid molecule can form this group because they contain dash group and dash. So how esters are formed? Which two groups react to form the ester? Now the question is, lactic acid molecule contain the lactic acid molecule form this group because it contain both group. So this is the structure of the lactic acid. So as you can see, the structure of a lactic acid, what it contain carboxylic group and it contain OH group as well. So it has both carboxylic acid as well as alcohol. Is the formation of a polylactic acid is addition or condensation polymerization, and I give a reason for your choice. Like this is a polymer formed from this monomer. Is this polymer formed by condensation polymerization or addition polymerization? So it is formed by condensation polymerization, and how we conclude that, or how we said, because the monomer does not contain carbon-carbon double bond, because to be addition polymer or formed by, and because there will be a water molecule released when carboxylic acid react with alcohol. So both ways you can justify your answer. The answer is it is a condensation polymerization, and reason for that, the monomer does not contain carbon double bond with carbon. Or you can also mention, this is one reason, one way you can write, the monomer contain alcohol and acid, the carboxylic acid, which result in formation of water. So as a result, the water molecules will be released or given off. That's why this polymerization is a condensation polymerization. Part C, when lactic acid is heated, acrylic acid is formed. So complete the word equation for action of heat on lactic acid. So this is a lactic acid, it forms acrylic acid. And what else will be there? A lactic acid is heated, it forms acrylic acid. But what else will be there? Can you work out from this? So there will be water as well. Why there is water? Because you can see in acrylic acid, it does not contain OH. So H and OH being removed. So when H and OH being removed, so there should be H2O. And this, when they are removed, so there will be a carbon-carbon double bond. So the word equation of lactic acid is acrylic acid plus, because H and OH being removed, so plus water will be there as a product. Then describe a test that could be used to distinguish lactic acid from acrylic acid. Both are acids, so we cannot do a pH test. But there is one more thing. A lactic acid contains carbon-carbon single bond, where acrylic acid carbon-carbon double bond. So how we can test to show the presence of a double bond? Yes, so react with halogens, or simply you can mention bromine. Add bromine. With lactic acid, no change. But with acrylic acid, it will decolorize. Means the color of the bromine will disappear. Why the color will disappear? Because